Okay, welcome to another Orbiter 2010 video, and in this video we are going to continue our flight, or we're going to continue the explanation of how to go from the moon to drop down to the Earth to get that gravity sling and then go off to another planet. In this example, we're going to Venus, and again, we're not worrying about, doing a complete mission here necessarily. We're not getting into the fuel planning and the locks and all that. This is just to explain how to do this because it's a very cool thing that you can learn, and Dimitri taught me how to do this a month or so ago. I think he actually showed it to me a while back, 2 or 3 months ago maybe, and I just couldn't retain it. But we sat down, I remember, a month ago, and we went over it 2 or 3 times, and I recorded the session when I was talking to him on Skype, so I could have it as my record. And I've gone back through it a few times, and I now have it. I now understand it very well myself. So I wanted to make a video for my YouTube channel to show other people how to do this very cool thing. And if you like this, if you think it's neat, leave a comment down below and thank Dimitri, because again, he's the one that showed me how to do this. And I think we were actually planning on doing a video on this at one point, but we were having a hard time figuring out basically how to make the video because, at the time I didn't know how to do this, and we were spending like 2 hours just trying to explain it, and it was hard to figure out how to make a video. So anyway, I'm going to just jump back into it. Let me switch camera views. In the last video, we did our second level of refinement. Remember, in the first part, we brought we had the moon where it was at a 90-degree angle to the antipode position, and then we figured out, what our eject date would be based on that. And then we had to do a second level of refinement where we got the moon to where it was at a 45-degree angle to the antipode position. Then we got our eject date based on that. Then we did a third level of refinement where we brought the moon down to where it was about at a 22-degree angle, 25, something like that. And again, if you're going to the outer planets, especially the bigger ones, then that third level probably is never going to be necessary. But as you're going in toward the sun, things are moving faster, they're spinning around the sun faster. So it's just, the timing is a lot more sensitive. So again, I would imagine if you're going to Mercury, you would probably might even want a fourth and maybe even a fifth level of refinement on this whole eject date thing. But we are ready to go. We set up our plan here. At the end of the last video, we got everything all ready. But the one thing that we have left to do is we wanted to bump the clock forward. Remember, we want to go forward by 0.15 based from where we are at right now, or where we were. And that's going to be 57143067. So I'm just going to fast forward time to that point. And when I do that, we want to watch here, because remember, when you set up your plan, it's based on whatever the clock was when you started setting it up. So we're going to have to reset the date, so let's just get ready to do that. All right, now again, it's going to be 57143067, so let's go forward to that point. 02, 03, 04, 5, getting close. 6, 1, 2, 3, and we're almost there. There it is. Okay, now again, we want to reset the date, and you'll kind of watch what happens here. Dimitri kind of showed me this as a way of trying to help explain why we do this. Fast forward of 0.15. If you look at where the moon is at now, you can see, it's gone a little bit farther ahead, from where it was before. And as I reset the date, you're going to watch this whole thing. It's going to shift ever so slightly. Reset. And basically, I guess the idea is that helps us arrive at Earth's periapsis at a better time. So that's the reason that we do that additional 0.15 on the date. Let me bring up the scenario editor and just get rid of some fuel. We've got way too much fuel in the Delta Glider, and it just makes everything take longer. So if I cut the fuel all the way back to, like that, that's more than enough for this mission. Let me just double check and burn time calculator real quick. Yeah, that's still we could dump even more than that. But that just lets us get to orbit faster. So let me bring up orbit MFD over here, projection, distance, and we'll leave the frame at ECL. Go back on this side and make sure we have the escape plan up. We do. And bring down the adjustment level and make sure that it's now where it needs to be, because we did fast forward time just a little bit. Okay, so we need to lift up and head to a heading of 252.2, and then we'll use TransX as our guide to help keep our relative inclination down to a low number. All right, so here we go. All right, first of all, let me think about this for a second. 252, exactly behind me is 270. So it's actually a little bit faster, ever so slightly, if I rotate to the right. Okay, lifting up and going to 252.2.
Rotation.
Put in a bit of rotation, maybe take out some hover already so we don't climb way too fast. 252.2 is the number we're looking for. Start slowing down. A little bit more. And right about there, full power on the main. Get rid of the hover, pitch up. And we just want to pitch up enough to keep the velocity vector right above the horizon and no more. And let me do an adjustment here on our line because it's getting pretty far out already. Pitch up just a little bit more. Looks like my heading's just a tad bit off. And you don't really need to obsess over the heading. Dimitri kind of tells me, or has mentioned to me, that I obsess over it a bit too much on my ride to orbit. But just a habit, I guess. Okay, the velocity vector is above the horizon, so we'll kind of go back more to a level position. Again, we don't need to worry about it. Okay, we just overshot a little bit of our heading there, I think. Everything's looking pretty good. Just got to watch the APA now. And, oh my gosh, I can't believe I overshot by that much. It comes up on you so fast. Usually I kill it and I'm off by, you know, a kilometer or two, but not by 30 kilometers. That's ridiculous. That's not acceptable.
Translation.
Okay. Now that we are in orbit, of course, one of the things we want to look for is when we're going to reach apoapsis, and we can see that we've got a whole half of an orbit to go before we reach that point. And we're going to cross the eject point before then, so we don't have to worry about circularizing our orbit. It's just not going to be a priority for us. All right, let me just quickly check here. If I put the white line over top of our present location, we are 0.007 and the number's trending upward. So if I actually just put in a little bit of a lateral translation, and I say lateral because I'm currently facing wings level. If I were in the prograde position, I would need up-down translation. But I'm just going to put in a touch of lateral translation to bring the relative inclination down a little bit. Okay, now we are on track to set up the next part of our plan. We need to go back to TransX instance number 1, and we need to basically copy our moon to Earth plan over to this instance of TransX. And for starters, we have the PE distance is already set, but if it wasn't set, we would need to set that, but it's already set, so we're good there. And I'm going to go to view setup then, and we're going to change graph projection to something else that makes more sense, like focus. Scale to view to target. And now we're going to go to maneuver mode, turn maneuver mode on. And we're going to set the, we should probably get a little bit closer to the time to begin the burn before we set this up, but I'm going to go ahead and set it up now. And the amount of prograde that we need is going to be 821. So let's put in that number. We can just enter 821. And for the maneuver date, we can't quite do it the same way that we do in other plans, where we just bump the date forward until this line lays over top the other one, because the other one is on that instance of TransX and we can't see it. So if we go to view target we can see the time to begin the burn is here, and we just want to make it match the time to begin the burn over there. So we'll go to, and actually it's actually faster if you, actually I was going to say it's faster if you go to maneuver mode and go to mandate first, but apparently it's not because it's still not there. And the thing I don't like about the target view is there's so many variables to go through, but it looks like we just have to go backwards. If you go forwards, sometimes you're going forwards for like days. You can see how many variables there are. It just takes forever. So if you go forward by more than 2 or 3, try going backwards. Now I'll go down to just something like probably like an ultra setting, because we need to go forward by 1,000 seconds. So ultra should be good. And I'm just going to put in ++ until I'm close to that number. And we're getting pretty close. Now let me go down to a hyper setting. And we're just eyeballing it. But you can get very accurate with the eyeballing, and you can see now it's about 1 second off. So let me just subtract. Actually, it's a little bit ahead. So okay, well, and if we need to, we can even go down to the micro setting. And there, we're pretty well matched exactly. But again, if it's not exact, it doesn't matter, because you're going to be doing you're going to be doing several adjustments with the date here in a moment anyway. Now, the next part of the setup is something that I actually left out when I did the the Mars to, or rather the Earth. What was it? The Moon to Earth Sling to Mars video. I left this part out of the explanation because I didn't remember that you had to do it. But anyway, we're done with TransX 2. So let's bring up TransX 1 on this side. And let's view, let's actually go back to the maneuver over here. And let's view stage 2 on this side. Again, I read left to right, so I like to have like anything that the input on the left side and the output on the right side. That's just the way my brain works. So let's view over to the escape plan and go to eject orientation, and let's spin the eject orientation around until we find the lowest relative inclination. And it looks like it's about 4.23, something like that. And we can also see that our focus PED is 8,000. What is that? 8,020 kilometers, whatever it is. It's not 6.53. It's not 6.571, and that's what we need it to be. So what we want to do is we want to bring the focus PED down to where it's 6.571. And if you're knowledgeable of TransX, you're going to say, well, why even bother doing that? Because the focus PED isn't accurate, and that's true. But we're going to use IMFD's map program when we actually do the burn. But in order to get the timing calculated correctly, we need to have the correct focus PED, even though the whole math model thing in TransX is off. We still need to have it set correctly so that we know the right eject point. So we need the focus PED to be 6.571, and we need the relative inclination to be, lower than what it is now at least. And we can start that. We can start adjusting things by date, and that's why it doesn't matter if you get the date to match exactly right, because now we're changing it anyway. And as I can see, if I put in a little bit of plus, it's bringing the focus PED down, but it's raising the relative inclination. So let's switch over to the prograde variable. And we want to go down to, like either hyper or ultra. Now let's just see what does what. If I put in plus, okay, that's bringing down the focus PED, and it's bringing down the relative inclination. So that's having the desired result. So let's go to a super setting. And we're going to bring it way down. Okay, let's start by getting it set where it needs to be set. 6.571, close enough. And let's again do a quick adjustment here on our eject orientation to see what we have. And it's still pretty far off, so let's work on that. Again, the very lowest it's ever going to get is 4.1, and that's not until we're all the way on top of Earth. So we're going to have to go back and forth here between the prograde variable and the date in order to bring down the relative inclination and simultaneously keep the focus PED at about that point. So we're just going to take out some more time. If I take out time, that's bringing the relative inclination down, and it's raising the focus PED. Okay, that's okay, because I know that when I add in prograde, I can fix it in the other direction. So start there. Now prograde. Let me check this. Okay, I've got the PED down quite a bit, so let me go back to the date. And I also like to re-update every few seconds while I'm doing this. Okay, now the date is going the wrong way, so or rather the PED is going the wrong way. So now you can see the relative inclination is coming way down, and the focus PED. Let's get it back to the normal number, the 571, or very close to that. Now let's adjust our eject orientation again and see what we have as the low number. It's still 1.3, it's still pretty high, so let's kind of swing it out this way a bit. And let's go back to prograde and add in some more prograde. That's going to lower the PED, but it's also lowering the relative inclination. Now back to do an update, then back to the date. And we're going the wrong way, so let's take out some date. And we may have overdone the prograde, so let's check. Okay, we're still getting benefit by taking out date, and it's still bringing up the focus PD and taking down the relative inclination. Swing that around some more. Okay, I think we're about as low. We're getting close to the lowest we're going to get just by date, so I'm going to have to work a little bit more with the prograde, and it's going to be negative prograde. Just need to get closer to that 571 figure, about there. Now let's go back to the date. Let's do an update. And that's pretty good. Let's do a check here to see where our low point's at. Still 0.11. Of course, it's a lot better than 4 point whatever it was. So let's not reset the date. Okay, there we're at 6.574, basically right where we need to be. Let's just check our number here. So this is very low. We've got the relative inclination under control. It's just minor adjustments as we go back to the Earth. I don't know exactly what you want it to be, but I would say 0.1 or lower probably is a good starting point. You don't have to get it down to 0.000. In fact, I don't think you can or ever will. And even if you do, it's not going to matter in the slightest, because as you leave the moon's going to tug on the vessel all the way back to Earth, and it's going to change your relative inclination. So obsessing over it down to several decimal points is just a total waste of time. But I will go back to prograde here for a moment and see if I can just get that set perfectly at 6.571. That's the wrong way. Okay, so we have 6.571, and we have a relative inclination showing of 0.05. But if we kind of swing it around and find the very lowest point, it's 0.04 at, when we're really close to the Earth. But we will do mid-course corrections when we're more like out here. All right, so that part of the plan is set up. Now we can press VW on this side to get over to the target view. And what I'm going to do now is fast forward time until we are about 300 seconds away from the time to the burn. Then I'm going to go into the maneuver and do an update just to check everything out to make sure that it still makes sense. So let's do that now. Let's warp time forward. Let me double check orbit MFD. We're here. The eject point. Okay, yeah, apoapsis is 2000. Just double checking. The last thing you want to do on a plan like this is, skip your circularization burn and run into the moon. Okay, fast forwarding time down to 300 seconds. We'll go with that. And VW over to the maneuver. And we're going to go to the base orbit, hit update, and just watch over here. You can see things didn't really change much. That went from 571 to 572. We're not going to worry about it. So the maneuver's good. We're going to VAR until we find... Oh my god, there's so many variables here. I really hope TransX gets updated again so that when you're in view target, it only shows the variables that are relevant. There's so much stuff that it shows in this. It basically shows all the variables, and most of them just aren't relevant. So we're going to go auto center, use that handy dandy feature. Not worrying about fuel savings and all that again, because this video is not like a whole mission of Delta V planning and all of that. I'm just simply trying to log how to do this process, and it's as much for my own benefit as it is for anybody else. In fact, it may be exclusively for myself. I don't know if anybody cares enough about this type of planning to even do these types of missions. But if I don't do this for 5 or 6 months, I'm going to be really rusty on it. So later this year, August or something, I might want to come back and do this. So by having these videos as a log, and I can just refresh myself quickly, oh yeah, that's how you do that. Okay, now we're coming up to the time to do the burn here pretty quickly. So we're going to bring up interplanetary MFD on this side, and we're just going to use it for its map program, because remember, its map program is very reliable. We're going to reference the Earth, and we can turn display lines on, we can shut the annoying auto zoom off, and we can turn the SOI on, and that's it for that. We can page back over here, and we want to I guess we want to select so that we can see the PEA and stuff instead of the APA stuff. Now, since we don't have a plan turned on, as soon as the burn starts, this is going to update, and we're going to watch the PEA in interplanetary MFD to help us know when to stop burning, because it works out for whatever reason that the delta V that you see in TransX is always going to be, I can't say always, but in a lot of cases, it's about 6 to 10 meters per second more than you actually need. So if you want to prevent overshooting, then you'll, instead of watching the delta V countdown, watch the PEA countdown, and when you get down to 500 kilometers or so, get ready to kill the engines, or 1,000 kilometers, something like that. Get ready to kill the engines, and then do just forward backward translation to get your PEA set where you want. And when you're done, you'll see that your delta V in TransX is going to say that you still have like 8 or 10 meters per second left to go. At least that's the case for going to Venus. I don't know if it works out differently for other planets, but when going to Venus, I find consistently that there's always several meters per second left over. All right, let's warp time forward. Okay, getting ready to do the burn in 5, 4, 3, 2, 1, burning. And we can warp time forward. Come out of time warp, watching the PEA, and kill the engines, and I still managed to overshoot it. Okay, so turn auto center off. That's the very first thing you want to do when the burn's done, and then switch to translation. And take out your mistakes, if you have any. And you can see the delta V in TransX. Again, it's like 8 or 10 meters off for whatever reason. And And if you were planning a DV freak mission, this kind of thing would drive you nuts. If you know, when you overshoot and you have to, you know, undo what you did because it just feels like such a huge waste of fuel. All right, so and again, make sure you turn auto center off. It's very important. I've noticed that if you forget to do that, and you then switch over to maneuver mode and turn maneuver mode off, but you have left auto center on, that it creates problems when you do your time warp. That's probably a bug, at least it might be. So it might be worth, I might mention that to Enjo, that when you turn maneuver mode off, it should automatically turn off auto center as well, because it doesn't seem to do that. Okay, well, we're close to 30 minutes, 25 minutes on this part of the video, so I'm going to go ahead and end it here. It's a good stopping point. Let me go ahead and save my plan. I've got TransX over here, interplanetary over here, doesn't really matter, but at least I've got TransX up. So let me Control S to save just in case things blow up on me. And when we come back, we will talk about what we have to do between the trip from Earth down to, rather between the moon to Earth. We don't just want to simply fast forward time all the way to Earth's periapsis, because there are some mid-course correction considerations that we need to take into account. And that should be the last part of the video. The next one, we should be able to take care of everything else, because again, I'm not going to do the whole flight all the way out to Venus. We're not going to worry about that. I just want to show how to do this setup and how to do the burn. I probably will fast forward time to at least show you that we're going to make it to where we're trying to go. But beyond that, we won't worry about like the actual completion of the flight. And I'm probably going to do, like I said, at least one more of these videos, a whole from scratch, a whole video going out to Mars, and maybe even do a third one trying to go to Mercury or something like that. Because I just feel very passionately that when you're trying to learn how to do something, when you see one tutorial on how to do it, if you don't follow that tutorial verbatim, word for word, then you can't figure out what's going on. And when you try to deviate and you're like, well, I don't want to go to the ISS, I want to go to Mir, and things are different when you go to Mir, just ever so slightly. But if you don't know how to make those adjustments in your head, then you can't figure out how to deviate from the plan. So that's why I want to show multiple examples of how to do this, because when we go to Mars, things are going to be at least a little bit different. Not a lot different, but a little bit different. All right, so that's going to be it for this video. Again, if you like it, like it. If you didn't like it, don't like it. And subscribe to the channel if you're not already subscribed. Please check the description down below for links. Primarily, I have an FAQ that a lot of people never seem to notice, and they ask me questions. And I don't mind the questions. I love the questions. But they ask me the same stuff all the time, and I just point them to my FAQ. So if you have questions, check that out first. It'll probably answer a lot of your stuff. If you have questions beyond that, especially if it's related specifically to what we're doing here, please definitely leave those questions in all the comments down below, and I'll be happy to answer those. And if I can't answer them, I will forward the questions to Dimitri, and I promise you he can answer them. So I will see you in the next video.